Newton's third law, remember the first law, object at rest stays at rest until acted upon by an unbalanced force. Object in motion stays in motion until acted upon by an unbalanced force. Newton's second law, F is equal to m times a. Newton's third law says, well, we learn it as for every action there's an equal and opposite reaction, right? That's not the way we like to state it. We like to state it as if object A applies a force on object B, then B will apply an equal and opposite force on object A. Why do we state it that way versus that way that you learned it in grade 5 or grade 6? For every action there's an equal and opposite reaction? Well, because this reminds us that it's two objects that we're dealing with. The forces don't cancel. Equal and opposite forces on the surface should cancel each other out. But they don't here because they're acting on separate objects. One of them is acting on object A, and one of them is acting on object B. Take a look at this diagram down here. Right, if I state it as for every action there's an equal and opposite reaction, then maybe I draw one object and these two forces should cancel. That's wrong. I've got two objects. There's a force acting on one object and there's an equal and opposite force acting on the other object. Because it's two separate objects, they don't cancel each other out. I said a few minutes ago when we were talking about this that Newton's third law on the surface is the easiest one, right? Every action, there's an equal and opposite reaction. It's not the easiest one. It's sometimes, for some people, the hardest of the three laws. When we state it as for if object A applies a force on B, B applies an equal and opposite force on object A, that leads us to a better understanding, but it's still a bit confusing. I've got a fist punching some glass here. Let's say, for whatever reason, I got mad, I don't know why that would be, and punched this glass and broke this glass. My fist is object A, the glass is object B. Okay, I break the glass. Okay, I'm not punching the glass and not breaking it. I'm breaking it. My fist is object A. Object A applied a force on B, the glass. The glass applied an equal and opposite force on object A. Oh, maybe Newton's third law doesn't count when the glass breaks. Does it? Does the glass apply an equal and opposite force on my fist when it breaks? I think we'd agree that if I punch the glass and the glass doesn't break, that the force it pushes back with is the same as the force I pushed it with. Agree with that? I punch the glass with a force of 50, it punches back with a force of 50, if it doesn't break. But what if it breaks? Ben? There would still be some resistance, but if I punch it with 50 and it breaks, wouldn't resistance be more like 30 or 40? Yeah. So Newton's third law doesn't work if it breaks. No, it absolutely works every single time. Now, if I punch the glass at 50 and it doesn't break, it pushes back with 50. Okay, we agree on that. Okay, clearly 50 newtons then isn't enough to break the glass, agree? So I break it this time. I must have pushed with, I don't know, 60, 70. Let's say I pushed with 75. I punched it with 75. The glass breaks. It punches back with, or it pushes back in my hand, Dylan, with 75 newtons as well. Why does it break? Why doesn't my hand break? Because my hand was tough enough to take a 75 Newton force. Guess what? The glass isn't. Make sense? That's all there is to it. It doesn't mean that the glass isn't pushing back with 75. It just means that when I punch it with 75, it breaks. It's not very strong, but it still pushes back with the same force. Newton's third law always applies here. What if, hey, what about this? What if I threw a rock through that window and it went right through that window? It went right through. Slows down, of course, when it goes through, right? But it goes through. I'm not just breaking it, it goes through. The rock applies a force of 60 newtons on the glass. Listen, the glass can't possibly apply a force of 60 newtons back on the rock, right? Because the rock keeps going right through. Did it? Absolutely it did. Absolutely. If the rock applies a force of 60 on the glass applied a force of 60 on the rock. Why did the window break and the rock not break? Because the rock's stronger than the window. The rock can withstand 60 and the window can't. Why did the rock keep going? Because 60 newtons wasn't enough to stop a rock. Right? Try applying a force of 60 newtons on a train. It's not going to stop a train, right? Maybe it doesn't stop a rock either. It's still the same force. Does that make sense? Always. Okay, I promise you this right now. On your unit test, one of the multiple choice questions is going to involve a little object, a little light object hitting a big, heavy object. And the question is going to be this. When the light object hits the big object, which one applies the bigger force? And I know that some of you will say, oh, the big object applies the bigger force because it's bigger. What's the answer to the question? The forces are equal and opposite. The force on the big object is the same as the force on the little object. It doesn't make any difference. Maybe the little object breaks, maybe it doesn't. The forces are still equal and opposite. Yep?
How did we prove this?
How do we prove this?
Yeah.
Well, I'm sure there's been a million experiments done to demonstrate Newton's third law, but mathematically we can prove it as well.